All right, so we've basically been dealing with one sample sampling distributions, and now we're going to look at the difference, meaning that we're looking at two populations. So this means that I'm looking at the true proportion in population 1 and population 2, and ideally what we're going to do is take two separate independent random samples from each population. That way I can generalize to each population, and I can ensure that population 1 has no influence on population 2. Now that might assume that we are doing a random sample. Now we could also look at this in the case of treatments, treatment 1 and treatment 2. So I look here, and again, we will look at population 1 and population 2. And I'm looking at the proportion of successes in each treatment group. How successful were they in reducing the pain level? Or was there a difference between the genders or some type of variable that we blocked on? So we're going to look at two groups now. So group 1 and group 2, and this is just, again, these symbols are all arbitrary. You can call them group 1 and group 2. It's just important to identify them. And thankfully for us, the conditions do not change much, if at all. So we're always going to look at the sins of statistics. Now, the only difference here is the I, since we have two groups. Not only do I want independence within each of my samples through the 10%, but I want independence between my samples. So group 1 does not influence group 2, and so forth. So again, S means stated random. Again, this could be through SRS or random assignment. Independence, we're checking too. Independence between the samples. Were they taken separately? Were they in separate treatment groups? Are they from separate parts of the country? Who knows? But then also independence within the sample, meaning that if I'm sampling without replacement, my sample sizes respectively are no more than 10% of their respective populations. And then lastly, the approximately normal or the large counts condition, but I'm going to check each population separately. So just an extra step here in checking it twice. So we are looking at the shape, and if the successes and failures within each group are at least 10, then the shape of the sampling distribution of the difference of sample proportions is approximately normal. The center here will just be the difference between the means, and this comes back to our work with random variables, showing that you can find the sum or the difference of the means just by performing that operation. And then lastly, the standard deviation is this formula here, and that's just going to be dependent on the fact here. Nope, you don't need to see that or that. Here we go. So you don't have to bother to memorize these formulas. Again, they are provided for you. So for two populations, here's the mean, here's the standard deviation, and then here is the standard error. And the standard error occurs when we're looking at the sample, because again, in the sampling distribution, we assume we know the population. So that's the big difference between P, the population proportion, and P hat, the sample proportion. So a bunch of hoopla. Let's get into what this looks like. Let's suppose we have two populations and I want to find their difference. That'll give me the center. Then using the 10% condition and using our Pythagorean theorem of statistics, we can find the average distance, the spread of the distribution, assuming the 10% condition is met. And then lastly, the shape depends on the large counts. So let's take a look at an example here. And suppose that there are two large high schools, each with more than 2,000 students in a certain town. At school 1, it is believed that 70% of the students did their homework last night, whereas only 50% of the students did it at school 2. Now, the counselor at school 1 will take an SRS of 100 students and record the proportion that did their homework. And the counselor at school 2 will take an SRS of 200 students and record the proportion that did their homework. Now, the two counselors are going to meet to discuss the results, and after meeting, they both report to their principals that the sample difference is about 10%. So let's go ahead and construct our sampling distribution. So before we can construct, we got to commit some sins. So I know I typed mine out. You're going to have to write yours out. The second semester is all about technical writing, so just, yeah, you're going to really get a workout on your wrist. So let's take a look at the first condition, stated random, and we were told that we'd used a random sample of 100 students from school 1 and a random sample of 200 students from school 2, and that was told to us in the form of an SRS. Next up, we check independence between the schools, and I'd say it's reasonable to assume the schools are independent of one another since they came from separate schools. Next up, we check independence within the sample, and we do so by looking at the 10% condition. So if my sample size is 100, that times 10 would tell me that I should have at least 1,000 students in the population at school 1 and 200 times 10 would say at least 2,000 students at school 2. And this is reasonable because we were told they are both from large high schools and there are more than 2,000 students. So in either case, the 10% condition is not violated. And then lastly, we check normal counts. So I'm going to take the claimed proportion and I'm going to multiply it by my sample sizes. And when I do so, I get 70-30, both of which are greater than or equal to 10. And I get 100 and 100, also both are greater than or equal to 10. So now I can proceed with using my formulas here. And if you need a moment to copy down the conditions and just pause the video. All right, awkward pause over. Now, I'm going to use these formulas to construct my sampling distribution. I'm going to take the difference between the proportions and then use my formula here to find the standard deviation. So this is mostly just computation here, and you can see that again, my term, my formula, my work, my answer. So when I substitute in the formulas here, I get that the difference in sample proportions is approximately normal with a mean of 0.2 and a standard deviation of 0.0579. So the difference in sample proportions, here's our large counts, here's our random, and here's our 10% condition. So I first start by verifying the conditions, and then I use a formula to find what those parameters are. Now, let's suppose that I want to find the probability of getting a sample difference of 10% or less from the two surveys. So that's that I want that my sample proportion is less than 10%. Well, I convert that to a z-score, and the probability of getting a difference that has a z-score less than negative 1.73 is going to be relatively small here at 0.0418. And again, if you don't know where those values are coming from, I'm using my formula sheets, and I found here negative 1.73. And when I find its respective probability, that comes out to about 0.0418. All right. Next up, let's suppose that I want the probability that a higher proportion of students at school 2 completed their homework than at school 1. So again, we have to be able to go backwards. So the value won't always be specified. Sometimes you're just going to look at the difference. Now, honestly, if it just gives you a difference, just go and order the first one, then the second one. You can have a negative difference, but most times they'll define it for you. So here, we want that p hat 2 is greater than p hat 1. But we've already had our distribution defined for us as P1 minus P2. So I'm just going to rewrite this probability statement here to accommodate for that information. So I want the probability of getting a sample difference between the sample proportions no more than 0. Well, we're going to get a very low z-score, and looking at my normal curve here, negative 3.45. When I find that, negative 3.45 on my table, it's only about a 0.0003. So there is a very small chance that there's going to be a higher proportion of students that completed their homework at school 2 compared to school 1. Now, this is just, again, a bunch of hoopla. It basically just means that if I were to look at population 1 and population 2, take all possible samples and then take all possible differences and plot those differences, I would end up with a distribution that has these characteristics. All of the differences would be within these bounds of the standard deviation, and we'd expect for these differences to closely approximate the true population difference. So again, this is just going to be a matter of verifying conditions and using the formulas to find those said parameters. All right, so last example here, and then we'll get on to the next lesson. You can see the work here, so I'll just narrate what's happening. Darren and Josh are pretty good free throw shooters, and Darren makes 75% of the free throws he attempts, whereas Josh makes 80% of the free throws. We're going to take separate random samples from each and record the proportion of free throws that are made by each. Then we want to describe the sampling distribution of p hat d minus p hat j. So I'm told here are the claimed proportions, and here are the respective sample sizes. I had separate, so they're independent. I had random samples of 50, and 50 free throws. We can expect that the population is definitely at least 500 free throws for both guys there. And then the last one is if I were to check the large counts condition, I would get 37.5, 12.5, 40, and 10. So since all of those counts are at least 10, I can use a normal model. So again, I'm just going to sub into the values here, find the difference, and I get that the sampling distribution of the difference of the sample proportions between Darren and Josh is distributed normally or approximately normal with a center of negative 0.05 and a standard deviation of 0.0835. Again, looking at the conditions, verifying them using formulas. That's all we're doing here. And then lastly, I just treat this like a normal model problem. We find the probability of obtaining a sample difference of a sample proportions of at most 5%. So meaning that the differences between their two proportions is at most 5%. Again, that 5% on this normal curve has a z-score, falls at 1.2. So the probability of getting a sample difference of at most 5% would be somewhere at about 88%. Pretty good. So we will do some more practice in class with this lesson, but we're just looking at two populations, taking the difference between the two, and then plotting all possible differences to get an idea of the sampling distribution of the difference of the sample proportions. And again, I could be comparing the difference of the effectiveness of treatments, the difference like the proportion of left-handed people from America versus Europe, the difference in people who are Buddhist in Canada versus in Asia, etc. So I'm just comparing the differences between two different populations. But that's going to wrap up our second lesson here on sampling distributions. And now we're going to start transitioning into quantitative data. So the last two lessons have been categorical, and now we're going to look at the power of looking at means and quantitative information. So stay tuned.